that correctly. He presently works with the ITU and he coordinates and manages the ITU AI and machine learning in 5G challenge. He received his master's degree and PhD degree from Yokohama National University. Prior to joining the ITU, he worked as a research engineer in the engineering department of Microwave Factory Co. Limited, Tokyo, Japan. He has won several awards for his works, among which are Japanese Government Scholarship 2017 NEC C&C Foundation Non-Japanese Researchers Grant, Best Student Paper Award at 2016 IEEE International Workshop on Electromagnetics, 2018 Young Engineer of the Year Award by IEEE APS Japan. He has co-authored several peer-reviewed journal and conference papers, predominantly in the area of wireless communication and antenna engineering. His interests includes machine learning, deep learning, and network science and their application in wireless network. We will all benefit from the wealth of knowledge of Dr. Thomas today. He is presently on the call. He will be taking us on the topic breaking into AI in 2021 and beyond. He will share his advice on how to effectively enter the industry and excel. Dr. Thomas, you have the floor.
Thank you so much for the kind introduction as well as for the kind invitation for me to join you today. So I would like to keep this informal and also maybe interactive. So I would just like to go quickly through everyone on the call. You just maybe introduce yourself and of course your goals or what you're doing, something quick, maybe 30 seconds, just a quick, pitching. So yeah, let's start. Anyone who is on the call, let's start.
All right, good evening. Yeah, I'm Joseph from Nigeria, and actually work in the industry. Okay, let me start with my background. I studied mathematics. I graduated, say, 29. So I work with a big four, and I'm just passionate about learning. Well, I'm already in the industry I'm already into machine learning and the likes, but I want to further expose myself to the field and learn from people that are in more in the industry more specifically. So I am just interested in knowing and in developing my skills in the applications of ML in finance. So I think that is all.
Thanks a lot. Next, anyone?
This is a man from Japan, communicating with someone in Japan. They lie. Okay.
Anyone introduce? Just quick intro. Let's keep this interactive.
You received and in the engineer in Japan.
Not the capital of Japan, not Tokyo.
Hello, everyone.
Okay, go ahead.
Sure. My name is Eric. I'm from New York. I'm a software engineer, and I'm looking to just understand a little bit more about artificial intelligence. This is the beginning of my journey. Thank you.
Okay. Anyone else who would like to give a quick intro? Okay, I will be trying to make this one not so much formal. So maybe can I share my screen? And then we will go through this journey. It's quite an interesting journey of course, I don't want to dwell much on myself, but I would like to understand your journey as well, and then we can see, maybe give each other some advice or some pointers on where do we go from here. But it's quite an interesting field. So, okay, so let's break into AI in 2021 and beyond. Now, as I would like to thank for the nice introduction. So I will just a small run about myself. I'm Thomas. I am from Malawi. So maybe some of you don't know, it's a small country in Southern Africa. And I graduated my bachelor degree with a double in physics and mathematics. And then after that, I went for my master's and PhD in engineering. And I'm a wireless communications engineer, to be specific. So I graduated with electrical and computer engineering PhD. And basically my research was on antenna engineering as well as signal processing. So you can understand the depth of the mathematics that is involved in signal processing. And most of the mathematics or the techniques that are used in signal processing are the same techniques that are being applied to machine learning. So it's quite a nice union of techniques as well as applications where you can see that what you are doing or the skills that you get in one field can be applied in other fields and still get very interesting results. So apart from studying in Japan, I also worked in NEC. I believe maybe some of you know NEC from maybe the TVs or the projectors, NEC projectors. They are in two different fields for communications. I think in the Tokyo 2020 Olympics, they're the guys who installed the communication, the ICT infrastructure, the communication. They also provided some technology for face detection, for the athletes. Just instead of putting their ID, showing their IDs all the time, you have the face detection AI system that would just open the gates for them, and also for the crowd control. So that because with the COVID, you understand that you cannot be this much people in some cafeteria. So this system could detect the number of people and say, okay, this is crowded, we stop allowing people to enter. So these kind of technologies developed by NEC, and also I worked for MWF. And then since 2019, I moved out of Japan and then came to Geneva in Switzerland. I'm working for ITU. It's a International Telecommunications Union. I believe maybe some of you know ITU, some doesn't know, but we work on 3 different mandates. We develop standards, so international standards for ICTs, for telecommunications, the bits and the bytes. This kind of, for example, the video that we are doing now, this platform, we are using the video standards. This is part of ITU work. So you have the JPEG format for photos. You have the HEVC standard. This is for video coding. These are developed by ITU, of course, in collaboration with IEC, ISO. And then in ITU, I'm working on Machine Learning 5G Challenge. This is a global challenge or international challenge where people are applying machine learning as well as AI to communication networks, as well as autonomous networks. So this is a different field altogether, but this is part of my work. So this is a simple overview about myself and my journey. So if you have a question, please, you can stop me at any time, and then we can continue talking. Okay, so next I would like to just give a quick round about AI. my assumption is that most of people here know about AI, know about the differences between AI, machine learning, deep learning. My assumption is that we have some understanding. So I wouldn't go deep into the details. I would scratch the surface and then give some pointers, of course, some views according to my experience as well. But maybe just to brush up our memory, if we forget, AI, artificial intelligence, is kind of the big set, and then machine learning the subset, and deep learning the subset. So in AI, what the ideas is that we want to mimic or to imitate the human behavior. A machine should be able to perform some tasks that a person can do. And in this case, of course, you run into issues about, okay, do you mean that you want machines to replace us? Or do you want the machines to do work that we don't like to do? So it depends on which way you look at it. But I tend to believe that we would like to use these machines to help us in our day-to-day lives, to make our life easier, because you don't want to do same task over and over again, just repeating the same thing, while you can delegate it to a machine to do that menial job or not interesting job for you. So that's a quick roundabout artificial intelligence. And machine learning, which is a subset of AI, is just a computer trying to learn from the data. So you throw some data on the machine and you develop a mathematical model. I'll use a mathematical model or algorithm, because I have mathematics background, so I like to call them not algorithms, but call them mathematical models. But anyway, which way you prefer it, okay, you can say an algorithm or a mathematical model, but it's all the same. So you throw data at it, it try to learn, you train it and it learns, and then it can give you some prediction, or it gives you some insights into what is in the data. And if you give it new data, it will be able to give you some kind of result, or we call it inference. So there is like several examples that we can say. For example, if you we'll go to the quick, simple example on images, you train your model on millions or thousands of images, and then it should be able to, if you give it an image of a tree, it should be able to tell you, okay, this is a tree, or this is a person, this is a dog, this is a cat, these kind of things. And then a subset of machine learning is deep learning. These are algorithms that analyze data with a logical structure, just like a human brain. So in this case, most of the times, the machine learning models, they're a little bit, I would say, simple in nature, but they are not really simple. But if we compare the machine learning and deep learning models, I think the machine learning models are a little bit simpler as compared to the deep learning. In the structure of deep learning, you have like a number of neurons that you have, and it's quite huge, can be very huge. It can go up to, I would say, hundreds currently, but I would hope in future to go to thousands of neurons that you can train. So these are just simple discussion, but then currently, if you talk about matured application areas, why I'm saying these are matured? They are matured because you can rely on the inference or on the results that this system gives you. And many companies, individuals, they're just using it and they don't think that this is AI. In most countries, or I would say, in most countries, people are using, let's say, Google Translate. You get a text from someone in different, or you see a text online, you see, I don't understand this language, you just copy, paste, and you see the output, and then be like, okay, I understand what is going on. So you trust that the AI is giving you almost an accurate response or an accurate result. So these are that I'm calling matured application areas. So we have computer vision where you detect, you can detect something or a video or image. You should be able to classify those kind of things, and also recommendation systems. And why are these areas mature? One thing I would say is that there is so much corporate interest. Many big companies have put so much resources in these type of problems to just get accurate results, as well as there's so much data sets out there, and the data sets are just in good shape. They're just very good type of data set that you can find. So because you have very good data set, we have very good computing power, as well as we have very like interest of major corporations in this kind of problem or in these areas. You find that we have very good models, state of the art, they are well benchmarked. You can see in this graph, you have the ImageNet. And until now, we have like above 90% accuracy, top one accuracy, which is really very good. And because of this, you can see now that you have safe driving cars. Some companies are putting on the road cars because they know that the computer vision AI or systems or models that they have like very good accuracy and very low errors. So they can still believe, or they can make sure that these are good systems to be put on the road and they don't have some problems. So these are application areas that are mature, and of course they are very easy to get into. So the level to the barrier is very low now because you have so much resources out there. So to get started, it's very easy to get started in these kind of areas. So if you have a question, you have a comment, then you can just stop me at any point, you know. Yes, so if there's a question, please. Okay, if not, then I'll go to next. So there are challenges. I would call some challenges, but of course these are things that they will be there. They are not going anywhere. We have to deal with it. We can manage them in some cases, but in some instances we cannot. So NLP is natural language processing. So natural language processing, one simple example is maybe the translation. You take, let's say I'm from French speaking country and I'm texting someone who speaks English. I send them a text in French, and then they just take it and put it on Google Translate, and it translates to English, and they'll find the meaning. So that's one example, but there are several examples of natural language processing. Okay, so the challenges, one would be time scale. So this is a very good example in telecommunications. So in telecommunications, you have different, I would say, areas or different things that happen. You have time scales of days or weeks. For example, a telecom company would check in a month how many people subscribe to their network, or how many people left their network in maybe 1 year, or, you know, you have these dynamics that change over large chunk of time. And then you have some activities or actions that are supposed to be taken on maybe seconds scale. And then there are some actions that are supposed to be taken in millisecond scale. So what I mean is that if you are on a call, a phone call, right? You're calling someone, there is what we call quality of service, where you have to monitor the call that is in very good condition, And if someone is walking or driving, it means that when they are moving from one base station to another, then there should be a handover between these communication towers. Now, you have to make sure that as much as the core is there, it should not drop, and the quality should be very good. And these are, if you are supposed to develop or deploy an AI system that has to help you in quality of service, it has to perform to millisecond scale. So you have AI systems that can be deployed and then has to perform in maybe a week time scale, and some that has to perform and be deployed in a millisecond or second scale. So these problems with time scales make deploying AI, for example, in communications, way difficult. But these are also the challenges that makes the future promising. Another challenge, I would put it in domain knowledge. Because we have, currently we have so much resources, getting started in AI is very easy. But I think if you don't have the domain knowledge, it's still difficult to really break those bars, because you need to understand what is happening behind the hood. If something goes wrong, you have to be able to explain what was happening, what went wrong, and where you can fix. Because if you don't know what went wrong, you don't know where to start from to fix. Otherwise, you need to start all over again, which is not good. So domain knowledge is also a challenge, but also important and interesting. And the thing about AI is kind of a cross-section. Not only people who are computer scientists or programmers are the ones that are doing AI. It's totally different. Of course, programming is very good skill. It's a must to have to be in this field. But having a knowledge of a specific area you're working on helps so much. So if you are a computer engineer, you want to work on AI in some agriculture, you still need some knowledge, little knowledge about agriculture, how it works, what goes into it, so that when you are deploying your AI system, it has to work properly. And if you are an agriculture person, you want to develop AI system, you need to know some bits and pieces of maybe computer science, how the system works and how can it be of help to whatever you are doing. So this intersection is quite important, and it's also a challenge, because the barrier is low, it's easy to enter, but also it's difficult if you have a problem. So you have to balance these two things. And last, this is data sets. I would go back to the same slide before. Here, matured application areas. These are mature because there is high quality data sets. In most fields, there is not so much data sets available. That's why there is no benchmark models in other fields. But if you have high quality data sets, so much resources put into that, I think we can advance so much in terms of AI and application in different areas. So where can you start from? One thing I would say is that you can start from anywhere, and you don't need to have a PhD to get started in this journey. That's not the idea. You can as much as you have the vision, you have the motivation, and you want to work in this field, you can start from anywhere. Now, it's easy, but also it's quite interesting, because you can get overwhelmed with the amount of resources that are out there, and sometimes you don't understand what is best and where is best to start. So first, you have to pick the field of interest. Are you interested in, let's say, image or videos, or maybe some application area like health, agriculture, whichever you want. So when you pick your field of interest, understand the basics from that field of interest, but also understand some basics on machine learning. What are the basics? In my case, I would say some simple, maybe some few mathematics courses and statistics courses. I think my recommendation, if you were to ask me what would you recommend, I would recommend to do calculus, linear algebra, differential equations, and probability. So if you have these 4 courses in your bag, I think you are good to start. And then when you start from there, you also need to do some courses. So currently, I would say that for machine learning or AI type of applications, Python is, I would say, is still popular, still gaining more popularity, and you have 2 boxes that helps you to develop different types of applications in Python. So if you understand how to run some simple programs, you understand how these things work, you take a few courses. I have a list of areas, like places where you can get started from, and then practice. Practice is way important. If you don't practice, then you will be left behind, because every time there's always something new that is coming up, something new that is, you 2 weeks, you find there's new benchmark, 6 months, another benchmark. So you have to practice and be on the edge. And as well as maybe one thing I would say, that trying some competitions also helps. There are a lot of competitions out there. It doesn't mean that getting into a competition you have to win, but the idea is to learn. What can you learn in that competition, and what is the outcome? You don't need to, okay, I want to get money, I want to be the number 1. It doesn't mean you don't have to be number 1, but what do you learn from those kind of competitions? Because each competition has different objectives, and if you can finish it and you learn something, it puts you ahead. So these are some of the things that where you can start from. So there is a question about recommendations for NLP. I would, okay, I will give maybe like all around recommendations, because I think the recommendations that I'm going to give will help not only in NLP, but in other fields as well. I think getting started can be of help to any other field. So maybe in my next few slides, I'm going to give some pointers. Okay, here. Resources that can get you started. I did say, okay, on the bottom here, to grab the concepts better, have background in calculus, linear algebra, probability, and differential equations. Of course, you don't need to know everything. Calculus and linear algebra, I think these are the best. So if you can try to learn some calculus, some linear algebra, it's good enough. But if you want to develop, maybe develop some models, then I would encourage you to start with machine learning courses. I think for deep learning AI, the Professor Andrew has some good materials on machine learning that was taught in Stanford when they were starting Coursera, and I think it's one of the most popular courses is machine learning. It's a very good course, so I would recommend that you take that course. After that one, if you are still interested, you can take deep learning course. So the deep learning specialization on Coursera has applications in several fields. You have natural language processing is part of it. And of course, there is another specialization just for natural language processing. But still, you have several techniques that you can learn from deep learning AI courses. So I think that's where you can begin from. But if this is too, it can get maybe overwhelming, it can get maybe more deep. There is other introductory courses on Coursera, edX, Udemy. YouTube has good resources as well, but you need to dig deep. And if you want to get your hands dirty, because getting your hands dirty is the best way to learn. You have to do it. You have to write the code. You have to train your models. You have to know the performance and compare with others. So you can start on your computer. Most of the computers you have is like good memory. You don't need to have a very big model to develop. Just a simple laptop, you can run a model. Of course, it can take hours. If you have some GPU on your machine, on your laptop or desktop, better. If you don't, there is free resources, but of course, free is not free. You know, sometimes you think, okay, I'm getting something for free. You understand, oh, in fact, I was charged. So you have to be careful with these free resources. So we have Google Colab. You can get a free account, free tier, and you can be able to run some models. You have Cargo, where there's competitions, but also you can still manage to get some models up and running. There is AWS SageMaker. You have Azure and the notebooks. So I think Google Colab, AWS, and Cargo can get you started well on the free tier program. Just make sure that configure your account such that when you finish training, you remove everything, then you don't get charged. Otherwise, when you leave everything and you forget about it, 7 days pass, you start getting charged and you don't understand where is the charging coming, where is the money coming from, you know. So that's my advice. And of course, GitHub had so many resources. Most people that are working on this field, they make their work open source. So you have GitHub repositories where you can see what others are doing. And of course, there's so many open source projects where you can also contribute. There's a lot that you can do. You can contribute, but also gain something in the process. So I would say, what are the interesting areas now? There is a lot of interesting areas, I would say, but one is AI in communication networks. So currently in Europe, Asia and other areas, they have deployed 5G. And of course, in Africa, you have South Africa, Nigeria, and a few places that are also deploying 5G. So future communication or communication networks, these are, I think you have to look out for the future where the applications, the AI is just going to be tremendous. And 6G is going to be almost entirely AI based. So it means there's so much work in future that you can do. And other field, AI for health. If you are a medical doctor, a nurse, or a health practitioner, you can still use AI in your field. Of course, if you are not a medical person, but you're interested in medicine, you can use your AI skills to apply in the health sector. For example, you can use computer vision, maybe images to detect some disease, or to detect, let's say, to develop an app that can detect if you are maybe bitten by a snake. You can take a picture of the snake and the AI can automatically say that, okay, this snake is poisonous or has venom and is dangerous, or this snake is okay, you don't need to worry. Just go to the hospital. You know, these kind of things. So there is a lot that you can do with AI in different fields. We have also in transport, autonomous driving, self-driving cars, road safety. There's a lot of work that has to be done in these fields. Environment. There is one example I can give about the environment is that currently we have so many data centers, right? And these data centers consume so much electricity. And in telecommunications, the idea now is that we also use data centers for communications in future. So you have small data centers, they're called on the edge cloud. But how can you make sure that these data centers are environmentally efficient? One is that you can, let's say, see in a day, there is time where you have so much traffic and there's less traffic. You can make sure that when there's less traffic, you have an algorithm, a machine learning model, or you have an AI system that can predict that, okay, at 6 p.m. there's less traffic, so we have to switch off all other machines that are working because they will not be needed. And then at 8 p.m. traffic starts going up, it starts switching one machine at a time until you reach the peak. And when the peak is reached, when you are going down, it starts switching off. So in this case, it means you are reducing the amount of carbon footprint because you don't use so much electricity. You use you just use enough. You don't use too much. So there are a lot of applications that you can do for AI to help protect the environment. We have agriculture, we have education. You have so much that you can do. So these are some of the interesting areas. And what we are working on in ITU, I would just like to introduce the 5G challenge that I'm like managing and organizing in with different people from around the world. This is a global competition. The application is communication networks, but we hope that in future we are going to go into different fields. The idea is that we would like to replicate what happened in computer vision, where you have benchmarks, and each and every year you have very good results, and you are pushing the bar, you are pushing the limit. You have models that now companies have confidence to work with them in their systems. This year we had like problems or examples of problems that were in graph neural networks, whereby like the participants were asked to design a machine learning model that is trained on a simple network, maximum 50 nodes. But during inference or in production, it should be able to work on a node that is 300 nodes or 500 nodes. So it means that you train your model on a simple network, but it can perform in a very huge network without problems. And we get, I would say, groundbreaking results because the mean error was like less than 2%. So you can understand that people can push the bar really high. We also had another one on modulation classification. And in most cases, when people are designing their AI, they always want to optimize. It's either you have the cost, you reduce the cost, or you get accurate model. You cannot get both. But in this case, we were asking people to get both inference on computation as well as the accuracy to be very good, so that you don't, I would say you don't get one of the two, but you get both sides. And of course, we had one on radio link failure prediction. You can predict when maybe there is going to be some disaster and the radio is going to be not available, and you do the mitigation before the disaster happens. And of course, you have the reinforcement learning, which is not an easy topic because this is unsupervised learning and people are still working on this. So there's so much that people did this year and people are still doing it. And of course, these are some of the companies and hosts that helped us in this year. And we have the problem host. We can see that we have 14 problem statements. And this you can is tailored for both beginner and also advanced. So if you are a beginner, you have something to work on. If you are interested in some topic, you have something, because even federated learning, we had also some topics on federated learning. So you have almost everything that you need to work on. So if you're a beginner, you can start working on the baseline model, you learn from there, and then if you're advanced, you work on some advanced topics where you can develop your own model, train it, and push the bar. So this is the simple timeline, and we have the award ceremony in December, and the prices, we have 5,000 for the number 1, 3,000 for number 2, and 2,000 for number 3. But also we are going to have other prices. And the good thing is that with this challenge is more of oriented in both ways. If you are academic oriented or non-academic oriented, we tailor for you, because we give out cash prizes, but also we give opportunities for people to publish their results in journals if you are academic side. If you are on an academic side, we still have other opportunities, job opportunities, internship opportunities, collaboration opportunities. So, and other areas, I talked about AI for health. We are working on AI for health. So I think in the future, like there's going to be so much that you can do with AI application in health, dermatology, maternal and child health, fake medical detection, malaria, tuberculosis. There's a lot that you can do with AI in health. AI for environmental efficiency, smart manufacturing, industry 5.0, edge computing, nanotechnology, other areas. And I think I did rush through the slides because I'd like to have enough time so that we can have some discussion. So I would like to ask, maybe we can have some discussion, and what your thoughts, insights about the future, and what do you see and where do you want to start from?
Thank you so much for such a wonderful presentation, Dr. Thomas. It's really insightful. For me, some of the takeaway for me is what you said about practice. Whatever we learn, if we don't practice, we don't learn it more. When you practice more, you'll be able to internalize what you are learning. Also, he mentioned more about competition. Competition shouldn't be majorly to win. It should be focused more on learning on how to improve your knowledge about the AI field. So I believe with both, we will be able to create fantastic solution which will be able to improve our world. While we are still waiting for questions from participants, I would like to ask, what are some of some opportunities that you believe beginners can access for them to improve their learning in this field?
So opportunities to assess.
What are some of the opportunities that are available for beginners so as to improve their learning in this field?
I think in most cases, I wouldn't say that there is jobs ready, because this field is quite competitive. I should say this field is very competitive, but that doesn't make a beginner not competing enough because everyone was a beginner. So we have to understand that everyone was a beginner, started from somewhere. Now, I would say that showing your skills, showing your potential is quite helpful. Right now, if you are a beginner, I would say that working on some, I would say competitions or some problems, it cannot be a competition to win or a competition to, but just working on some problem and maybe having a GitHub repository where you can showcase your skills, because sometimes people just go through the GitHubs and, oh, this person is interesting, let's see what they have. You can get hired like that. Of course, showcasing your skills puts you out there, makes you visible, and can help you to get maybe your dream job. But also, it's not about, I say that it's not all about getting employed. You can do cool stuff with AI. And once you have your maybe system up and running, someone will buy it, or you can start your own business. There's so much potential because the field is huge. There's so much that can be done. So the sky is the limit.
Thank you. The sky is the limit for everyone, as far as we are able to put in the work. Another question I would like to ask is, what are some of the misconceptions about the AI field?
Interesting. Misconceptions. There are a lot, but depends also on how you look at it, right? So I would say that people confuse AI with robotics. Because when they think about AI, they just think about robots. Oh, you're building robots. Oh, you want robots to take over, what. But really, it's more than that. You can have AI system that is, of course, robots has, of course, some intelligence in them. And that's part of the artificial intelligence, of course. But it's just one area of application of AI. So there are a lot more areas of AI. And of course, some people believe that AI is here to take over their jobs. It's also a misconception to my understanding. But of course, it's up to us, the people developing the systems, to showcase that the systems are not here to take over people's jobs or to make other people unuseful, but it's here to help. As much as it is doing some kind of jobs, but it is also creating jobs. So it's more or less like we just need to shift our mindset to see, okay, this thing is here to help us, it's taking over this part, but it has created these kind of opportunities. Let's take over those opportunities that have been created. Because you can see that in most industries, you find that they have really difficult to get good, maybe data scientists, good data analysts, and good AI. I don't know if there is, I would say machine learning engineers, not AI engineers, but machine learning engineers. So yeah.
Thank you for that answer. Okay, Anusha, if I pronounce that correctly, can you ask your question? Go ahead.
You're on mute.
Can you hear me?
Yes, we can hear you.
Thank you for hosting this event. I didn't know about AI, so this is the first time that I'm learning about it, and it was so informative. Thank you so much. I have a question that how can we relate psychology to AI? Thank you so much.
Okay, how to relate psychology to AI? Depends. As I said, there is a lot more that can be done. You can. It's quite difficult question, of course, but there should be, or there must be some kind of application of AI to the field of psychology, psychoanalysis, maybe how people think, because AI is mimicking the way people think. So you want the machine to think intelligently like a human. So psychology is also about the mind. So I'm not sure if I can be a good person to answer this question because I'm more on the technical side, but I can maybe get some resources for you and maybe share what kind of applications AI is being used for in psychology. But I think in most fields they are using AI. I know in economics there is application of AI, education, there are so many applications of AI. So I have to check maybe and then I can come back to you.
Okay, thank you so much.
Yeah.
We can all signify we have any other question. Dr. Thomas, for example, in agriculture, there are a lot of solutions with regards to trying to classify disease in leaves, plant leaves, and all that. But this solution already in the industry improving people's life because there are a lot of challenges with regards to food security. Are these solutions already in the industry? And what are some of the things we should look out for with regards to
it's quite interesting what you just said. We have some, we call it IoT, Internet of Things. And fortunately, I think next week, in 10 days, we are hosting a webinar on tiny ML, tiny machine learning. So this is the wondrous world of AI. You know, how you can use AI on small devices and in developing countries. It's quite interesting because some people are using it to detect plant diseases and you don't need to be connected to the internet. You just put the model, already trained model on a camera or on your smartphone. You take a picture, it tells you this is the disease, you need this this kind of medicine or this kind of pesticide to treat your plants. The same thing, there is also just one colleague, I'm not sure they are from Uganda or Rwanda, they have published also on malaria. So they developed a system based on natural language processing. So they trained a system on sound. They took the sound of the mosquito that gives malaria. They trained their model, accurate model, and then they put it in like a room. So when there is a mosquito in the room and this AI system detects that, oh, is this malaria giving mosquito, it sprays, it starts the spray, mosquito spray, to kill the malaria giving mosquito. So there is interesting things that are happening in AI that you can develop, you can use it for several applications and interesting applications.
That's wonderful.
And next year we are hosting this challenge next year.
Okay, with regards to malaria, right?
No. To design
IoT.
cool applications on using tiny devices.
Okay.
It can be on malaria, it can be on agriculture, it can be on anything that you can think of. So you just have to come up with crazy ideas how you can use AI to help in different ways.
Wow. Thank you. Thanks for that information. We should all look forward to that challenge. We are running out of time. We'll be taking 2 more questions. Obina, can you ask your question now?
Okay, good afternoon. Thank you very much for this wonderful program. It's been really enlightening in the short time. And I want to thank Dr. Thomas for a very enlightening session. My question is just very quick. Please, are there scholarship opportunities for people that want to forward their education? I'm passionate about AI. I want to know what scholarship opportunities are available. I also want to know how we can maybe after this continue communicating with you for mentorship or direction, maybe on LinkedIn or something, I don't know. And then finally, you said something about a TinyML, 10 days time, a webinar. These things are already making us think. And I want to know, is there possibility for us to get such information of how to hook up and follow this curiosity?
Okay, so many questions, but thank you so much. I'm just looking at the, okay, I should have something in the chat right now. Okay, so in terms of scholarship, depends if you want to go for undergrad, for master's or for PhD, but in most countries that provide scholarship, they do provide maybe artificial intelligence based or machine learning based scholarships, or any normal scholarship works. That's number one. So if you are looking at, let's say, Japan, you have the Japanese government scholarships, you have other scholarships that they give, and you can study any field that you want. You are a medical doctor, you want to study medicine, you want to study psychology, you want to study education, you want to study computer science, you want to study artificial intelligence. It's up to you. As long as you get accepted to the university, they give you the scholarship. That's number one. There are other countries that gives a specific type of scholarships, but I'm not quite certain of which company is providing very generous scholarships. But on the training side, for example, on Coursera, you can study for free. You can audit the course. You go throughout the whole process. You don't get the certificate. You get the knowledge. At the same time, you can apply for scholarship, and they do really give out the scholarships on different specializations. So if you go to the Deep Learning AI website, you go to their specialization and you apply for some scholarship, takes some days, but you can be able to get the scholarship to study the specialization. If you pass, you get the certificate. It's so good. So there are several opportunities that you can do in terms of the scholarship. In terms of the functions that are happening, I did share this information. You can register on that, and then we will meet on the 23rd for the webinar. For the challenge, I think you will get more information on that website on how you can be part of the challenge and see what more things you can learn. And of course, I'm on LinkedIn. I'm happy to connect. I think I can share my LinkedIn profile, and yeah, it's always a pleasure to connect with new people. And of course, I promise that I have to answer some question. Is it Anusha, right? So you can text me, and I'll get some resources also for you to get started on maybe AI in psychology or different fields. So yeah.
Thank you very much. We really appreciate that. Is there any other question before we wrap it up for today? It has really been an insightful event and getting to know more from the wealth of knowledge of Dr. Thomas. Do we have any other question? Okay.
Hello.
Yeah, go ahead.
Yeah, thank you, Thomas, for the wonderful session. Please, I have a question, and then my question revolves around model deployment. Deploying models is kind of a little bit complicated, and sometimes you need an interplay or a mix of software engineering to be able to properly deploy your models. Yes, maybe there are cloud services, but on a personal level, it can be very difficult to use those services because of the prices and all of that. So how do you suggest, what are your advice on how a data science practitioner, or don't let me use practitioner, let me say an enthusiast, someone that is just breaking into the system, what's your advice on how such person should deploy his or her models?
Yeah, so model deployment is quite okay. We don't talk about it so much, but it's very important part of the work, because once you develop your model, what do you do it? You have to put it in production and see if it's performing as much as you want. But there is a lot of things that happens, because once you develop your model, you train it, you get satisfied with the maybe accuracy or the performance, you have issues on size. For example, the size of the model is too huge to be deployed in some setting. So now you have the issues of how to optimize in terms of a size or to prune the model, and then on which kind of machine is supposed to be deployed. So you can develop it on the edge, on your mobile device, on the computer. There are some free resources that you can use to deploy it or to check the deployment on your computer, but it's not an easy hack. You can also try to deploy it on your, let's say, mobile on the edge. So you can deploy it in your smartphone or on an Arduino board. There are several resources that you can use to deploy the model, to testing. But of course, the cloud services are the easiest way to go, but then they're expensive. That's true.
Okay, thank you so much, Thomas.
Yeah, thank you, Dr. Thomas. Can you give us something to take home, your final word for today?
Okay, so my final thoughts is that AI can be overwhelming because of too much information, but there is something for everyone. So whichever field you are working on, you will find something that you can apply AI to, and it's quite interesting. So practice, practice, and practice. And don't be in a hurry. You will get a hang of things. Sometimes something is difficult, some things is easy. Everyone learns differently, but in the end, you get a hang of things and you'll be good. So practice and do your best. So thank you so much for hosting me today. I had a wonderful time. It was nice to interact with everyone. I also learned a lot. So thank you so much.
Thanks so much for sharing
Thank you so
the
much,
wonderful
Doctor.
information with us. Thanks to all the participants for being here too. We'll meet on subsequent events which will be shared with you all. Thank you very much. Bye.
Yes, bye.